I take it from the discussions on D2L this week that many of you are working in organizations that have made really good use of natural language processing. I saw a lot of great use cases and a lot of good identification of what those text resources were. I think that over the last couple of years, this has become much more familiar to students than it was in the past. Tools like Claude and ChatGPT and Gemini have made working with text a lot easier. And so it's become kind of a no-brainer to just say, okay, let's just take all this and let's generate some insights. But that process used to be a lot more complicated. And so what I want to do with this sum up is to spend a little bit more time with the case and then show you some of the issues that were brought up and the tools and what they mean. Um, I did enjoy the discussions this week. I won't be spending too much time summarizing those, but I encourage you to read what your classmates are writing. That's lots of great ideas there. Um, okay, so remember that this was from Harvard Business Review in 2022, at the time when GPT-3 was the current model. And we've since gone to GPT 5.2. And we also have a variety of specialized models where you can get faster answers or you can get broader answers. And so there's so many options now. And of course, OpenAI is not the only game in town. So by talking about GPT-3, which at the time was sort of the leading edge model, it makes it seem like this much more specialized than it is. But the fact is, we just have so many great large language models to choose from nowadays. So it identified, three particular areas of strength for these large language models, including writing, coding, and something called discipline-specific reasoning. And before I come back to that, I want to take a look at one of these things that it mentioned, that is coding. So I did a lot of coding as my career, and so I've been interested in seeing how AI specifically has been affecting this particular career. So I'll show you something. So Google Colab has integrated artificial intelligence into its notebook environment. So the way coding works in a notebook environment is you, instead of writing individual scripts or program files, you just write basically a cell at a time. And this works really well for some functions where you just need to do a little bit and then look at the output, do a little bit more, look at the output. So the notebook model of programming kind of like is a real win for analytics kinds of applications. But of course, it involved knowing how to program in a notebook friendly language like Python. Well, so uh, because of these AI tools for helping, you really just have to be clear on what it is you want to do, and the AI will write the code for you. Now, you could also just get the answers from the AI, but that's a different thing. What we want to do is generate code that we can run multiple times. So if we have a new file we want to process, we'll have all the Python in place to process that. So I'll give you an example. I've got just a little text file here in my environment, and all I want to do is read it in and then do a word count of it. So basic natural language processing kind of function. So let me see, how do I do this? What's the code to read in a file? Well, I mean, I don't remember exactly, but let's just click this generate and say read in a file, or read in the file called myfile.txt, and put it in a string variable. Yeah, we'll do this just one piece at a time. Okay. And then once I've got that, I will click on go. Okay, so now, rather than using up my time looking up all that syntax, or maybe asking on Substack or whatever, I've now got the code right here. Okay, I don't know if it's going to run successfully, but we'll see. It's defined the file path, and it's got this nice error handling discipline right here. So what I just need to do is just run it and then see if it runs. Okay, and it looks like it did. So it says file content successfully read into file content. Okay, great. So now I've got code for reading that whatever file I need to analyze in. So let's go ahead and come down here and add a new one. So now we just want to print out what's in there. So I'll just, this one I know, this is not hard. Um, so it's called file content. That's the name of the variable. So just print what's there. Okay, and then this is all that's in that text file. Here is a text file. So now I just want to, maybe start with some basic NLP functions. I could count the synonyms, do the sentiment analysis, whatever. But here I'm just going to do the easiest, which is just, count how many words there are there. Again, I don't remember what libraries or exactly the syntax, but um, print out print out the number of words in the, so it's now called, oh wait, sorry, I haven't got the AI on. You used to be able to do it in here, but let's go ahead and, hold on. I don't need that cell just yet. So I'll go to, launch the Gemini help coding assistant, and I'll do, print out the number of words in the file content variable. Okay. All right. Don't know if it works, but we'll see. This looks pretty right. So it it appears to take the file content variable and then split it and then do a length and then a simple print statement. So let's see if this works. And the number of words is 5. Okay. So all right, we've already got that code written. Well, I've got this other code, that's kind of basic stuff, but what if I wanted to do something like, you know, get some code to do the same thing but read in this one, which is a little bit more elaborate. And I want to read it into a data frame and then do some numerical analysis of a particular column. So let's do that. Just do a whole new thing here, and I'll start a new code block. And uh, now I'm going to tell it, okay, so start the AI assistant, read in the file called my invoices.txt into a pandas. So pandas is a data frame library in Python, into a pandas data frame. Okay. Um, uh, when successful, print out the first 5 lines. So again, it's not actually doing that. It's generating code to do that. All right. Okay, so they're just kind of doing the same thing. This time it's doing this. All right, again, good error handling here. Let's see if this works. An error occurred. Okay, error tokenizing data. Expected 1 field in line 9, saw 2. Well, it's a good thing I'm actually an experienced developer. I know what that error is. It's a problem of the delimiter. It is looking for comma delimited by default, but it needs to have tab delimited. So I know that I just need to come here and tweak this right here and do delimiter, right? Delimiter is equal to the tab character, which is \t. Try it again. Okay, and there. And so now it's read it in. We've got all the data in there. There's that variable total. So now let's do a little bit more, add another code cell. And let's see, print from the data frame. Wait, once again, I'm in the code. I want to be in the AI window. From that data frame, print out min, max, and mean of the total column. Yeah, I don't know if this will work. It's the thing about coding demos. They work sometimes. All right. Okay, yeah, so here's the basic descriptive statistics of that column. Let's try something big. Again, I don't know if this is going to work or not, but we'll try it. Make a histogram of the total column. See how it works with visualizations. I don't know. Uh, all right, see if this works. Ah, there it is, right there. Okay. Now, so this is some pretty basic entry level kinds of analysis. But once you have the code for, doing this with the data, then any new files that you get, you can just run through the same thing. So you've got a kind of powerful thing here. Um, Now, how long would it have taken me to write that without the AI? Maybe an hour to get it all right, get all the syntax right, make sure the variables are right, cleaning the data. But there's a lot of imperfections that AI allows. And so I was able to do in just a few minutes what would have taken me an hour before. Now, as we saw, we still needed somebody with programming skills because sometimes you get an error with the AI generated code and you have to go in and manually fix it. Well, okay, so we're clearly not going to be getting rid of programmers. But what does it mean that you can now have uh, you know programmers that are 10 times more productive? That's going to change the way the whole profession works, right? So this comment that came from the case I thought was really interesting. Um, you need to start understanding how these technologies can be used to reorganize your skilled labor. The next generation of tools like OpenAI's Codex, which is similar to the Colab Gemini assistant I just showed you, will lead to more productive programmers, which likely means fewer dedicated programmers and more employees with modest programming skills using them for increasing number of more complex tasks. This may not be true for all software developers, but it has significant implications for tasks like data processing and web development. Okay, so big implications, but there's going to be shuffling around. But it's not just a simple matter of, okay, we don't need this many anymore. We're going to, it opens up more opportunities and different kinds of skill sets. So another thing that it mentions in here, so it talked about discipline-specific reasoning, and it did uh, well, so an example of discipline specific reasoning were things like strategic planning, strategic thinking, and scenario planning. So just having these conversations with these LLMs, if they know your specialized vocabulary, if they know the domain, then they can actually come up with a real interesting set of strategies and you can do some interesting kind of divergent thinking with it. So it's actually can be a quite creative thing. Um, so uh, one example, so the case does talk about, one thing you have to do if you're going to do NLP is to identify your text data assets, and all of you did this really well in the discussions where you say, okay, we've got emails, we've got analyst reports, contracts, press releases, um, uh, shift transfer logs, archives, phone logs. Um, and so there's this recognition that domains have highly specialized vocabularies. And so a model that's trained on, let's say, marketing is not necessarily going to be very effective on, for actually, doing the summarization or topic analysis of something for finance. And they mentioned, so an example of this domain specific vocabulary is this Lauren McDonald Finance Dictionary, and I managed to get a copy of it. So this is for sentiment analysis, which, is like just categorizing text as, basically positive sentiment versus negative sentiment. And so they produced this document. Let's see how many. Yeah, 86,000. So they analyzed 86,000 words. And in the context of finance, they analyzed, well, are these generally in positive comments or in negative comments? And so I have them here sorted. So this negative column here, um, and these look like years, but they also encode the strength of the negative association. So if you sort them descending, we see that these are actually the most negative words in finance. So cyber attack, cyberbullying, cybercrime, mischaracterization, misclassifications, misclassify, misprice, redefault, spammers, underperforms. It's hard to imagine uh, uh, misdated. It's hard to imagine any context where these would be positive words, but there are cases where, certain word would be fine in finance, but it might seem um, insidious in other contexts. So let's try the positive ones. Sort these in descending order. Uh, okay, so positive, best, well, that's kind of easy. Innovativeness, able, abundance, abundant, acclaimed, accomplish, achieve, achieved. So these are all in the context of finance, these are all the very positive sentiment words. Okay, so that's just a nice example of, why it is that uh, NLP tools that are trained on one set of data may not necessarily work in a particular domain. Um, so one of the tools that this case discusses is something called elicit, which I have to admit is both impressive and startling for me as a professional researcher. So it said, okay, elicit is kind of a research assistant tool. It does summarization, data labeling, rephrasing, brainstorming, and literature reviews. So I gave it a try. A friend of mine and I are currently working on research on, what to do about students who are looking at their phones during class. And well, what are the interventions? What's been learned? What works well? What doesn't? How do we address this? Because and is it even worth addressing? Does the frequency and time spent on the phone really have learning impacts? Well, we wanted to know about this. So I gave it a try. You can just go to whoops, elicit, and it looks like the interface looks like this. This is currently I tried my wife's research, but I got the elicit report and I opened it up. Okay, so this was my prompt. I just said, phones are a distraction. What's the best way to deal with it? The goal is to create a good learning environment. What has been researched? Which ones still require more research and how they work? And it gave me um, a very nice version of something that I had been working on manually for weeks. Uh, so it gave a little abstract here about what's going on, and some intervention approaches. And then it told me that it looked through 138 million academic papers. And it analyzed, well, what populations were studied, what designs were studied, and then it created uh, this table kind of summarizing the studies and you know what their focus was, how they did it, what their population was, and these are real. These aren't hallucinated. I know from my own research that I actually studied all of these papers. And then it comes down here and says, okay, the three primary strategies were bans, partial restrictions, and something they call alternative approaches. But here they have the intervention type, all the studies that mentioned it, implementation details, blah, blah, blah. And then it looked at, the actual effects of the different interventions and gave a little summary here. And then it synthesized it and then discusses finally, limitations and, uh, you know, what's actually needed now. Where should the research go to kind of extend our knowledge of this domain? And this is shockingly good. If I had given this task to a graduate student, the graduate student would have disappeared for weeks and then come back with something fairly inferior to this. And I myself probably missed some of these analyses. So, and honestly, this did take me weeks. This is weeks worth of work, and it's lots of reading, and it's lots of papers to go through. But this summary is really quite good. It's astonishingly good. So again, the question arises, well, what's going to happen then? Two major components of my job are teaching and research. And this just cut off a big time consuming part of the research. And so, and with the teaching, the number of online options now, so we can imagine that there could be in higher education a major reshuffling of the sort that we could see also in development, where maybe we don't need people with PhDs, but rather with people with some AI skills and then some connection to practice and then so anyway, there could be just like a major restructuring. So there are very few positions that are probably immune to that kind of reshuffling. But I wanted to take some time at this point just to because I do think that natural language processing and the large language models are probably the most impactful and certainly the most immediate and raise those concerns about what tasks are going to be automated and how's it going to change the working world. We'll talk about that more when we get to the ethics and implementation unit. But uh, very nice discussion this week, and look forward to seeing more as we start to talk about deep learning, also called neural networks.